Hello and welcome to my YouTube channel Innovative Learning. Today we'll be solving Cambridge IGCSE Physics Paper 4, May-June 2021. Let's begin. Question 1. A skydiver of mass 76 is falling vertically in still air. At time t equals 0, the skydiver opens his parachute. Figure 1.1 is the speed time graph for the skydiver from t equals 0. So we have a speed time graph over here, and they're asking us in part A that we have to determine the deceleration of the skydiver immediately after the parachute opens. So in order to find out the deceleration or the acceleration, in both cases we have to find the gradient. And as we know that the formula of the gradient is y2 minus y1 over x2 minus x1. So we need two values for y and two values for x in order to calculate the gradient so that we find the deceleration. And in order to do that, we have to see this part, the beginning part over here, because they are saying that we have to determine the deceleration of the skydiver immediately after the parachute opens. So this is the part where the parachute immediately opens. And in order to find that, we have to draw a line over here, like so. And then we have to find the y values and the x values. Now that we know our y and x values, we can simply write them down into our formula of the gradient. So 58 minus 46 over 0.3 minus 0. So let's plug these values into the calculator. 58 minus 46 over 0.3 minus 0, and our answer is 40. So the deceleration is 40 meter per second square. Do not forget to write the unit. Your final answer can range between 35 to 43 meter per second square. It's totally normal. It's only because some students might take values like 48 or 42, like that. So it's totally fine. Depending on the values that you take, your y1 and x2 values will change, and accordingly your answer will vary between 35 to 43 meter per second square. Part 2. We have to determine the force due to the air resistance acting on the skydiver immediately after the parachute opens. Now, let me try to explain this visually. When the skydiver jumps off of a plane, the air resistance is less compared to his weight. But eventually, there comes a time where the air resistance and his weight are balanced, and the skydiver stops accelerating and falls at a steady rate called terminal velocity. It is at that point the skydiver opens the parachute, and due to increase in the area, there's a much greater force acting upwards, which is the air resistance. Now, there are two forces acting on the skydiver as he opens the parachute. One is his weight, and the formula for that is W equals mg, where it's mass into gravitational force. And the other force is the air resistance that is acting upwards. As the skydiver is moving downwards, there must be a net force acting upwards. Air resistance must be greater than the weight, then and only then the net force will act upwards. And this is the reason why the skydiver is decelerating towards the ground. Now we know that the formula for calculating force is force equals ma, mass into acceleration. So over here, since we know the net force, and the net force is the force of air resistance minus the weight, so we will input these values into the formula instead of the net weight. And W over here is mg. We will use that later in our formula. So force of air resistance equals ma plus W. And like I said before, W equals mg. So force of air resistance equals mass into acceleration plus mass into gravitational force. So the mass of the skydiver is 76, and the acceleration that we calculated from our part 1 is 40, the deceleration, 40, plus mass is again 76 into 10, and let's input these values. So 76 into 40 plus 76 into 10. This will give us 3,800. So the force is 3,800 Newton. Part B. Explain in terms of the forces acting on the skydiver his motion between t equals 0 and t equals 6 seconds. Okay, so for this we have to look at the graph and see what's going on. So if we look at the graph, we can clearly see that when the graph is sloping, the speed of the skydiver is decreasing. That means during this section, the speed of the skydiver is decreasing. And there must be a net force acting in the opposite direction of the motion. So the air resistance must be greater than the weight. That's why there is a deceleration over here. And then over here, we can see that the graph is horizontal over here, which means that the speed is constant and the forces are balanced. So we can answer this question like this, that initially the graph is sloping. This means the skydiver is decelerating because the upward force is greater than the weight. Deceleration decreases until finally weight equals air resistance and both forces are balanced. Part C. Explain why opening the parachute cannot reduce the speed of the skydiver to 0. So the answer to that is that forces balance at a speed greater than 0 and the speed cannot decrease once the forces are balanced. Question 2. Figure 2.1 shows a wooden trolley of mass 1.2 kg at rest on the rough surface of a bench. A ball of mass 0.52 gram travels horizontally towards the trolley. The ball embeds itself in the wood of the trolley. The trolley moves with an initial speed of 0.065 meter per second. Part A. Calculate the impulse exerted on the trolley. Okay, so first we need to write everything that we're given at the side, so it's easier for us to calculate. So we know the mass is 1.2 kg and the initial velocity, since over here they said that the trolley is at rest, so the initial velocity is 0. Then we have the final velocity, that is 0.065 meter per second. The formula for impulse is mass into final velocity minus mass into initial velocity. And since we know that the mass over here is common for both, so we're just going to take mass common and final velocity minus initial velocity. So let's plug in the values that we have from the question. Mass is 1.2. Velocity 1 is 0.065 and the initial velocity is 0. So let's plug these values into the calculator. Answer is 0.078. So the impulse is 0.078 Newton second. Once again, do not forget to write the unit. Part 2. The speed of the ball as it hits the trolley. So we have to calculate the speed of the ball as it hits the trolley. And in order to calculate this, we need to know that initial momentum should equal the final momentum. Let me write this over here. Okay, and the formula for that is mass of ball into velocity of ball equals mass of trolley into velocity of trolley. And since we have to find the speed of the ball, that is VB, we will make this as the subject and move the mass ball MB to the other side. So MT into VT over MB. So this is how we're going to write. And first we need to find out the exact values that we're going to put in this formula. So mass of ball, we know that it is given 0.52 gram, but we need this in kilogram. So what we'll do is we'll divide this by 1000 and we will get 0.00052 kilogram. Okay, that is our MB, mass of ball. Then mass of trolley. Mass of trolley, as we can see from the question, it says that the ball embeds itself. The ball embeds itself, so the mass of the trolley is basically the mass of the trolley plus the mass of the ball. So the mass of the trolley is 1.2 kg and the mass of the ball is 0.00052. So this will be 1.2002. And then what else is left? Okay, yeah, velocity of trolley, that we know it is 0.065 meter per second. So we can easily put these values in our formula now. MT is 1.2052 into velocity of trolley is 0.065 over 0.00052. So let's plug these values into the calculator. And our answer is 150. So we'll write the speed is 150 meter per second. Once again, do not forget to write the unit. B. As the trolley moves across the rough surface, it slows down and stops. Explain, in terms of the work done, the energy change that takes place as the trolley slows down. So the answer to this is that the kinetic energy of the trolley is used to do work against friction. The kinetic energy of trolley will gradually decrease to 0 and thermal energy is produced. Question 3, Part A. Explain in terms of molecules why liquids are very difficult to compress. Okay, so the answer to that is that liquids are difficult to compress since the molecules are very close to each other and the force of repulsion between the molecules is great. I have put a picture over here of liquid molecules. As you can see that they're very close to each other, and in between these molecules, the force of repulsion is also very great. So that's why it is very difficult to compress liquids. Part B. Figure 3.1 shows a device that uses liquid pressure to lift heavy boxes. The boxes are lifted by pumping oil into the cylinder. The force upwards on the piston due to the oil and the force downwards on the piston due to the air above the piston combine to produce a constant force of 8,800 Newton. The pressure of the air is 1.0 into 10 to the power 5 pascals, and the cross-sectional area of the bottom surface of the piston is 0.016 meters square. Calculate the pressure of the oil at the bottom surface of the piston. Okay, so first we have to understand what's going on over here. There is air pressure which is forcing downwards, the force is downwards, and then there is pressure of oil which is a force acting upwards. And then we have net pressure which is also acting upwards, and the net pressure is 8,800 newtons. So basically the net pressure is the difference between pressure of oil and pressure of air. So by keeping this in mind, we can simply write this formula right here. Net pressure equals pressure of oil minus pressure of air. And then we can make pressure of oil our subject since we have to calculate the pressure of oil. So when we make pressure of oil our subject, then the formula will be net pressure plus air pressure. And the formula for net pressure is net force over area. So we have force which is 8,800 Newton, and we also have area which is 0.016, and then we also have pressure of air which is 1.0 into 10 to the power 5. So we will plug these values into the calculator and we'll get the answer. This is a very lengthy answer, so I'll just write in standard form 6.5 into 10 to the power 5 pascals. Again, do not forget to write the unit. Part 2. As the boxes are lifted, the depth of the oil increases. Explain why the pump must exert an increasing pressure on the oil as the depth of the oil increases. Okay, so the answer to that is that pressure in liquid increases as depth increases. To oppose increased pressure of the oil, the pump must exert an increasing pressure. Part 3. Suggest one reason why the force of 8,800 Newton in Part B cannot lift boxes of weight 8,800 Newton. The answer to that is that initial force has to be greater than 8,800 Newton. Otherwise, it cannot lift boxes of weight 8,800 Newton. It has to be greater than 8,800 Newton. That is it for today, and I'll see you in my next video.